p-value. The p-value is used to measure the significance of the observational data. When we identify an apparent relationship between two variables, let's say we think there's a relationship between shoe print length and height. There is always a possibility that this correlation might be a coincidence. The p-value helps determine if the observed relationship could arise as a result of chance. The larger the p-value, the more likely it could arise by chance. To be sure that we're using data that actually is real and makes a difference and is not just happening by chance, we want the p-value to be below 5%, which is the same as 0.05. If you have percent and you want to go to a decimal value, 5% means 5/100. I can also say this is 1/20. What I really want is my decimal, and 5/100ths is the same as 0.05. I start with my 5%. I want to divide by 100. Every time I move my decimal place one place to the left, it gets smaller by a factor of 10. 0.5 is 5 divided by 10. If I move it again, that's 5 divided by 100. And inside here, I put my 0. And I can put a 0 out here. We get 0.05, which is exactly the same. That's a really nice, easy way to do it. Just move your decimal place. If my p-value is below 5% or 0.05, that means it is unlikely to be arising by chance. In this chart, this is the p-value that we're talking about, is this slope. And that is definitely bigger than 0.05 or 5%. That's actually 29.37%, which is very high. Because of that, we really don't know if there is a correlation. Interpreting a p-value from the previous example, the p-value of 0.294 is high. It shows there is a chance of getting a linear correlation coefficient of R equals 0.591 or more extreme by chance, even though there is no linear correlation between the two variables. So that p-value is too high. But if we go to the one where we had 40 points and look at my p-value, it's way less than 0.05, 0.05, and this is way less. 0.05 is greater than 0. Which means that it's very unlikely that this happened by chance. And look at my correlation coefficient. It got bigger, didn't it? It got bigger, meaning it seemed to become more linear. And my p-value is very small, which means there's a very low chance that it happened by accident. Interpreting a p-value from the example where n equals 5, because the likelihood of getting R equals 0.591 or a more extreme value is so high, it's at 29.4% chance, we conclude there is not sufficient evidence to conclude there is a linear correlation between shoe print length and heights. If I went back to here, I had 5 pairs of data for the one that I use. So I would come here to 5. My critical values are 0.878 and negative 0.878. Let's put 0 here in the middle. And my R value was 0.59, which is between my critical values. And when they're between the critical values, as we can see, there's no correlation. Here, because our p-value is so small, we have sufficient evidence to conclude there is a linear correlation between shoe print length and height. Let's do another problem. And it says for a data set of brain volumes, centimeter cubed, and IQ scores of 8 males. So 8, that seems important. The linear correlation coefficient is R equals 0.277. Use the table available below to find the critical value of R. There's my table. And I have 8 pairs of data. I come over here. I have my number line. I have 0.707. Let's make this 0, negative 0.707. We always have the plus and minus. And my R is actually right around here, 0.277. First, we put in the critical value. We put in either 0.707 here, and then you can put a comma and minus, or you can use this little plus minus, which means I want the positive and the negative of that value. Either way, whatever you like best. And that's perfect. Since the correlation coefficient R, what did we just say about the critical points? These are my critical values. And when R is between those critical values, we say that 0.277, and we put it on our graph, is between the critical values. There is not sufficient evidence to support the claim of a linear correlation. Remember, no correlation between the two values.